Great day, students! I am Teacher Catherine and welcome to your math class. The objectives are: first, illustrate quadratic inequalities; second, solve quadratic inequalities; and last, accept one's own strengths and weaknesses. But before we proceed to our lesson, let's have this activity. Which are not quadratic equations? Encircle them. Is it x squared plus 5x plus 6 is equal to 0? Is it negative 3x squared plus 7x is less than 4? Is it m squared is equal to 3m minus 1? Or is it 4x squared minus 25 is equal to 0? Is it x squared minus 2x minus 35 is greater than 0? Or is it 2d squared plus 7d plus 5 is greater than or equal to 0? Or 2x squared minus 8x plus 5 is greater than 0? Or r squared plus 10r is less than or equal to negative 2? Or is it 14 minus h squared is equal to 10? Again, which are not quadratic equations? Let's try to do this. Let's encircle. Alright, correct. It's negative 3x squared plus 7x is less than 4. Another? Yes, it's x squared minus 2x minus 35 is greater than 0. Okay, correct. It's 2d squared plus 7d plus 5 is greater than or equal to 0. Another one? Correct. It's 2x squared minus 8x plus 5 is greater than 0. And the last? We have yes. It's r squared plus 10r is less than or equal to negative 2. I am so glad that you still remember what are quadratic equations. You encircled not quadratic equations. So how do we call them? That is what I am going to discuss to you. Our lesson is all about quadratic inequalities. So what is quadratic inequality? A quadratic inequality is any inequality that contains polynomials of degree 2 and can be written in any of the following forms. Ax squared plus bx plus c is less than 0, or ax squared plus bx plus c is less than or equal to 0, or ax squared plus bx plus c is greater than 0, or ax squared plus bx plus c is greater than or equal to 0, where a, b, and c are real numbers, and a is not equal to 0. If a number line is divided into 3 regions, the 2 numbers that divide it are the boundaries. If the boundaries are indicated with open circles, then they are not included in the set. If they are indicated with closed circles, then they are part of the set. Examples. Number 1. As you can see, there is a number line. Negative 1 and 4 there are what we call the boundaries. That number line is divided into 3 regions. Negative infinity to negative 1, negative 1 to positive 4, and positive 4 to positive infinity. These are the interval notations for each region. Since there are open circles, meaning negative 1 and 4 are not included in the set or in the solution. And of course, we use parentheses if the boundaries are not included. In number 2, negative 2 and 5 are the boundaries, and the 3 regions are negative infinity to negative 2, negative 2 to 5, and 5 to positive infinity. If you will notice, we use closed circles, meaning they are part of the set. We use also brackets to indicate that the boundaries are included. We always use parentheses for negative and positive infinities. So that is how to illustrate quadratic inequalities. Let us now proceed to the steps in solving quadratic inequality. I prepared 4 steps. First, change inequality symbol to equal. Express the quadratic inequality as a quadratic equation in the form of ax squared plus bx plus c is equal to 0, and then solve for x. Second step is locate the boundary points. Locate the numbers found in step 1 on a number line. They serve as the boundary points. The number line will be divided into 3 regions. Third is choose a test point. Choose one number from each region as a test point. Substitute the test point to the original inequality. If it holds true, then the region belongs to the solution set. Otherwise, it is not part of the solution set of the inequality. And the last step is write the solution set, then graph. Write the solution set as the interval notation or show it as a graph. So those are the steps in solving quadratic inequality. This time, let us try. Let us solve and illustrate its graph. Example 1. Solve the inequality x squared is greater than x plus 2. So for our solution, as you can see, the given inequality is not written in standard form. So we need to rewrite it first in standard form. So x squared is greater than x plus 2. The x plus 2 on the right side will be transposed on the left side. So it will become x squared minus x minus 2 is greater than 0. And then, let's get its factors. So the factors are quantity x minus 2 times quantity x plus 1 is greater than 0. Then, let us now proceed to our first step. Change the inequality symbol to equal, or let's change the inequality into equation. The corresponding equation is quantity x minus 2 times quantity x plus 1 is equal to 0. So, x minus 2 is equal to 0 or x plus 1 is equal to 0. Then, you can have as x is equal to 2 or x is equal to negative 1. These 2 and negative 1 are what we call the boundaries. Then, let's locate the boundary points. So our boundaries are negative 1 and positive 2. And as you can see, there is a number line having 3 regions. From negative infinity up to negative 1. Second region is from negative 1 to positive 2. And the third region is from positive 2 to positive infinity. And then, let's have the third step. Choose a test point. So from region 1, I chose negative 2 as my test point. From region 2, I chose 0. And from region 3, I chose positive 3. And after that, let us substitute the chosen test points to the given inequality. And as you can see, from region 1, it says that 4 is greater than 0, which is a true statement. On region 2, it says that negative 2 is greater than 0, which is a false statement. And on region 3, it says that 4 is greater than 0, also a true statement. Then, we will take the true statements. To graph, since the inequality is greater than, then we will use an open circle and says that negative 1 and 2 are not included to the solution set. We have from boundary negative 1 to negative infinity and the boundary positive 2 to positive infinity. So the solution to this inequality is x is less than negative 1 or x is greater than 2. Let's have now second example. Solve the inequality x squared minus x minus 6 is less than or equal to 0. So since it is already written in standard form, let's get its factors. So the factors are quantity x minus 3 times quantity x plus 2 is less than or equal to 0. Then the corresponding equation is quantity x minus 3 times quantity x plus 2 is equal to 0. So you will have x minus 3 is equal to 0 wherein x is equal to 3, or x plus 2 is equal to 0 wherein x is equal to negative 2, and those are the boundaries. Then, we have this number line with boundaries of negative 2 and positive 3. Then I chose test points from region 1, I chose negative 3, region 2, 0, and region 3 is 4. Then, as you can see, as I substituted the test points to the given inequality, only region 2 will give us the true statement. Therefore, the number from negative 2 up to positive 3 are the solution sets. So, the solution to this inequality is x is greater than or equal to negative 2 and x is less than or equal to positive 3. Note that if the sign in an inequality is less than or equal to or greater than or equal to, then the number is included and it is shaded. Alright, thank you for listening. I hope you learned a lot. If you have questions, you can message me. On the next slides, it's your turn to answer. Do it and message me the picture of your answers. Now, it's your turn. I have prepared here, solve each quadratic inequality, fill in the blanks, and graph. Then try this, solve x squared minus x minus 6 is less than or equal to 0, then graph. And these are for your quiz. I prepared 5 questions. You need to solve each inequality and graph also. It's time to reflect. For number 1, kindly shade. How do you find the lesson? Is it a little bit confusing, easy, or challenging? For number 2 and 3, kindly fill in the blanks. I feel happy because I learned blank, and I feel accomplished because I was able to answer the following blanks. I need to learn more examples on the following blanks. Again, thank you and God bless. I am Mrs. Catherine D. Valle, your math teacher.